Okay, so as the normal distribution had parameters, the mean and the standard deviation, the binomial distribution has parameters of number of trials and the probability of success for an individual trial. Okay, so as I change these numbers, number of trials, if I reduce that down, you can see if there's 3 trials, there are 4 possible outcomes. Either no successes, 1 success, 2 successes, or 3 successes. And the probability of an individual success, the way I've got this set up, is 0.5 at the moment. If I reduce that down to, say, like a 6-sided dice, 1 out of 6 chance, whoops, I have to write what equals 1 out of 6, and I rolled that dice 3 times, the probability of, say, getting no 6s is 0.58, and say getting 1 6 out of 3 trials is 0.35, and getting 2 6s out of 3 trials is 0.5 or 0.06, and getting 3 6s, 3 dice in a row, the chances are quite slim, 0.001 or something like that. Can you see that bar there? It's very, very slim. Okay, so that's a classic binomial distribution. If I just change this back to 0.5, which is the problem that we were just looking at, flipping a coin. Let's change that back to... Okay, probability of success flipping a coin, probability of getting tails is 50%, agree? Now, this distribution, or binomial distribution, also has an average, right? It's a theoretical average, but it has an average and it also has a standard deviation. Let's change it to, let's flip a coin 10 times. Okay, well the average number of tails, say, would be 5, well the average number of heads is also 5. And the spread, do you remember standard deviation is the average distance from the mean, is 2.5. In other words, if I take 2.5 minus 2.5 and plus 2.5, what percentage? If we think normal distribution now. 1 plus or minus 1 standard deviation is 68%, right? Plus or minus 2 standard deviations from the center is how many? 90... Come on guys, 95? I know it's Monday morning, but... And then 3 standard deviations is 99. Thank you. One person's woken up. Okay, so, and I think I mentioned to you briefly, when this binomial distribution probability gets to 0.5, we can, it looks like the normal distribution, but when the probabilities are low, like 0.2, okay, it's skewed to the, what's that? Skewed to the right, okay, and it gets worse as the probability gets lower. Okay, coming back to our problem. Oops. Find the mean and variance for the binomial distribution, binomial random variable x representing the number of heads obtained when a fair coin is tossed 4 times. Okay. Parameters of the distribution. There are 4 trials and probability of success is 0.5. To find the mean, we multiply those 2 parameters together. 4 times 0.5, and the answer is going to be, what's 4 times 0.5? 4 times 0.5 is 2. Okay, so the center point of this distribution, and I can show you in a minute on the graph, is 2, and the standard deviation is just the square of the variance. Okay, I gave you this formula last week, but this word variance, don't get too scared off by it, it just means the standard deviation squared. Okay, so the question asks for the variance. We're going to calculate the variance using this formula here. If I were to wanted the standard deviation, I would just square root NPQ, and if you've used the textbook on page 150, Q is equal to 1 minus P. So you might just want to make a note of this. These were the two formulas we learned on Thursday. The mean is N times probability. This is a general formula, and the standard deviation is NPQ. How about I use a P there? Because then we've got P is probability, P is the probability, and Q is just 1 minus the probability. Okay, so filling out the numbers, and you can see there the answer is 1 for the standard deviation. Coming back to my graph, remember the probability, or the probability of success, is 0.5 for flipping a coin, and we did 4 trials. Okay, because the probability is close to 0.5, it looks like a normal distribution. And as we said, the mean is 2, so the center point, look, smack on 2, and then the standard deviation is 1. I've actually made a mistake in my formula up here, but I've luckily got the right answer. My formula, if you look at it, B4 times B2, 1 minus B2, is actually the standard deviation. Sorry, it's the actual formula for variance. To find the standard deviation, I have to take the square root. So SQRT bracket, bracket, bracket. But because the square root of 1 is 1, I luckily got the right answer down here. Okay? And that's what we did on Thursday. Make sure you catch up with page 150 and 151.